Hello, everyone. Welcome to the CIIR Talk Series. Thanks for joining us remotely and in person. Today, it's my pleasure to host, remotely, virtually host, Soboroff from National Institute on Standards and Technology, or NIST. Ian is leading the information retrieval group there. So the IR group at NIST kind of involves in organization of TREC, the Text Retrieval Conference, Text Analysis Conference, or TAC, and TREC Video Retrieval Evaluation, TREC VID, or TREC VID. I don't know what is the right pronunciation. So he has been involved in IR evaluation, I think, forever, as far as I remember for sure, but I think many others remember. And he's been a part of the core IR community. I'm sure you have met him at CIIR conferences and other IR-related or NLP-related conferences. Today, Ian want to talk about generative evaluation of generative information retrieval systems, a very exciting topic that I think a lot of people, not only at UMass, but also globally, are interested in, and they have no clue how to do it. We are all doing it, and I think we are all doing it wrong. So really looking forward to learning from Jan's talk. Before starting, I just want to share one fun fact. TREC was founded in 1992, and the CIIR was founded in 1992 as well. So we are as old as the main evaluation campaign of the IR community. Okay, without further ado, please join me in welcoming Jan to this UMass, even though virtually.
All right, thanks. Thank you. I actually wanted to share, my personal connection to UMass. I was not a UMass student, which is, I suppose, always to my regret. But a few months ago, there was an IR conference in Australia, and it's a long flight from DC, and I got there, and I'm in my hotel room trying to recover, and I get an email from the email address is BC, and it says, "I've got your luggage." And so BC was Bruce Croft, and it turned out that he did have my luggage. We have the identical suitcases with identical ACM luggage tags. And so my personal connection to UMass is that I'm in the perfect position to try and steal Bruce's luggage. If you've ever wanted to steal Bruce's luggage, I could tell you how to do it. Okay. Of course, I'm not here to talk about stealing about luggage. I'm just going to talk about generative IR. So let me share this window and play the show. Okay, and I could see that my slides are there.
Yes, we can see that.
Excellent. Okay. Yeah, I still got, all right. So yeah, I mean, Hamed is he's right. As I like to say, we're all bozos on this bus. We're trying to figure out the right way to evaluate generative systems. This is great, actually. Can you imagine how long it's been since in the information retrieval community we had no idea how to do something? It's been a long time. I think the last time we really had no idea what to do was the web. Okay, and we got over that pretty fast. So we don't know what we're doing, and so we're trying to learn it. So what I wanted to talk about is, what we're doing now, and how well that seems to be working, and what's our experience. Our experience isn't very old yet, but in some ways it's actually really, really old. So some of this gets into some broader questions about what do we want in an evaluation. I mean, beyond that little number that comes out of the end, what do we want in an evaluation? And then I wanted to give a history of generative evaluation at NIST and TREC and others, and do a bit of a deep dive into the summarization evaluations we did in DUC and TAC. DUC was the Document Understanding Conference. TAC was the Text Analysis Conference. And those are two things we spun out of TREC after we'd been doing question answering for a long time. We wanted to try and make a venue specifically for natural language processing. And I'm going to talk about the processes that come out of that. We tend to call nugget processes. There's a few different names for them. They're pretty manual and they're kind of labor intensive. So I'll talk about how we're thinking about trying to automate those, or how we're thinking about being able to automate those. And then I'll close with something I recently wrote that was recently published about why you shouldn't just ask an LLM if your system is any good. Okay. Now I'm kind of relying on folks down on the ground to field questions. I can answer questions in the middle. I can't see anyone. So people are going to have to either walk up to the podium and recite a question, or someone's going to have to repeat them when they come up. But I'm happy to answer questions. Okay. So beyond the average precision number, what have you, there's a bunch of things we really need to get out of an IR, or even an NLP, or even any kind of machine learning evaluation, if it's going to be useful to us at all. And so this is kind of my taxonomy. There might be other ones, but we want it to be diagnostic. You need to be able to tell the difference between systems. You want it to be explanatory. If you have a score, you want to be able to figure out why, so that you can make it better. It should be reliable. So, the performance on that test should be similar to the performance on any other test. If we imagine that these tests are a random sample, say, of all the IR topics in the universe that exist. We're not very good at that one yet. They should be robust, which means if I change the people making the labels, but the labels are still the same, system comparisons don't change very much. I want the evaluation to be reusable. Okay, I don't want to just measure people that participated in Trek, but when the people in Trek find out that they made a mistake, they should be able to fix their system and evaluate it again, okay, without me doing anything. And lastly, it should be replicable. I should be able to get the same scores that you do. And when we have systems that are pretty the same, we should get similar results. So these are things we want out of evaluations generally. I'm going to come back to some of these because some of them are particularly problematic for generative evaluation. So I asked ChatGPT, we have to talk about ChatGPT. I asked ChatGPT to create a photorealistic image of a 70 billion parameter neural network large language model, and this is what ChatGPT thinks of itself as. I don't know how you think of ChatGPT, but we have to be amazed at this kind of burst in technology. Actually, for this community, for IR, we're changing paradigms. We're moving from a classic paradigm of search, where users formulate queries, systems find documents matching the queries, and it ranks them for the system. And it does that matching and ranking based on a whole bunch of different signals, like your words, but also your behavior, also maybe your IP address, things like that. And going beyond documents, having info cards, blocks at the top of the search results that summarize information, or give you the link directly to the site you want, or bring you some key references, things. So this is search, as we've been working on it for, I guess, since the 1960s. Okay. Into now, we have generation, right? So the user formulates a query, going to the ChatGPT website. The user formulates a query or asks a question, and the system generates a response. And that's it. Now, of course, we know that these systems don't actually think. They don't really know anything. They're optimized to predict the next token after a whole bunch of other tokens have already happened. So really, it's taking your query and predicting a sequence of tokens that follows that, right? So another trick to this is to formulate the query and have the system on the back end do a bunch of things like searching to fill a really long prompt buffer, and then generate a response using that. And if it's especially clever, it can actually generate citations back into the searches and other things it did behind the scenes. And that's pretty important, of course, because one of the nice things about search is that when you click on a document in the web search, you know that the information in that document came from the document you clicked on. That seems obvious, but in a generated response, you might not have any idea where that information came from. And if you ask the model to tell you where it came from, it will cheerfully make up an answer for you that is usually non-existent. We're playing a lot with LLMs here at NIST, and we just set up a machine with a really huge model, and they asked me to poke at it. So when I get these things, I usually go in and ask it lots of questions to try and get it to screw up. So I asked it about how the Jews killed all the Nazis in World War II. And it repeatedly told me this was not true, which I thought was very nice, more than I expected. And then I asked me to tell me a citation where it had that information from. And so it made one up. It was a book that doesn't exist. But that's the best it could do. So anyway, part of the point of this talk, or the undercurrent, is that generation is not entirely new. We've been working on generative tasks for, I guess, about 25 years. And in the IR community, those tasks were question answering and summarization. So these are tasks where the system does generate, it doesn't return search results. And we've had a lot of experience trying to figure out how to evaluate those. In fact, I wanted to kind of see if I could put on one slide all the stuff we've done on generative. And so things really start back in 1999 with the beginning of the question answering track in Trek. Okay. There had actually been question answering efforts in the IR community before that, but this was the first attempt to systematically evaluate QA performance. And this moved through a lot of different phases and levels and permutations, trying to think about how to design this problem and make it more, better to evaluate and also closer to what people actually wanted to do. So for example, in the beginning, we told systems that they had a 250 byte buffer to give answers to. And so what systems tended to do, what people tended to do, is to pack the buffer with as many right answers as they thought might exist, so that maybe one of them would be right. So that's not really useful to the user. So we quickly changed to forcing systems to give us exact answers. That was in 2002. At the same time we were working on question answering, we had just started a conference which trying to be focused on summarization. This was the Document Understanding Conference, or DUC. DUC was a spinoff, and Donald Harmon, but also Karen Spark-Jones was really heavily involved in it. And really some of the things that Karen said about summarization really actually are really important today. And I'm hoping later on in my slides I'm going to get to talk about them. But one of the most important things is that you can't measure the quality of a summary or a generated output if you don't know why the person wants it. If you don't have any idea about what the person's going to do with that output, you don't know how good it is. Okay. In some sense, the system is giving you the most generic output, but you might need something different. You might need something you can tell to your teacher in high school. You might need something that you can use to start a background search in graduate school. You might have a genuine question you don't know the answer to. These are all different tasks, and you can't measure the quality of the output without having a concept of the task. And that was Karen's flag in the summarization area for many, many years. Anyway, so the penultimate point of this, I guess, is that, we have a pointer here, I think. Hold on. No. That here, last year, Trek had 1, 2, 3, 4, 5, 6, 7 tasks that all focused on generative outputs in some form or another. Okay, so went from kind of dabbling, having one track here, one track there, doing different kinds of things. All of a sudden, 2024 comes, and as well as I do, nobody cares about rank lists anymore. It's all about generation. So we have 7 generative tracks last year. Part of the reason we have so many, actually, is we merged the Attack conference and the Trek Vid conference back into Trek. So you notice in this list, some of these tasks are video. So these came from Trek Vid. And some of these tasks happened in TAC. And they, of course, also migrated into Trek. Okay. Oops. Oh, hold on. How do I get rid of my annotation? There we go. Clear all drawings there. Wow, this technology is so cool. Okay, so let me talk about these tasks and what we did with them. So question answering is the evaluation in Trek starts in 1999. We have these short, direct questions like who invented the paperclip? Okay. It's a short question. It's a factoid. It's a piece of information that's kind of in isolation of any other context. It's got a short answer. You could give me a long answer if you want. In fact, Henry Petrosky wrote a whole book about this. But you can imagine that the answer to this has a 2 or 3 word answer, which is the person's name. We initially wrote questions by hand. Later on, we actually took them from search logs. A lot of that came from Microsoft in various forms. Sometimes we had questions that didn't have answers in the collection. One of the rules was that you had to return an answer that was actually in the data collection. And so you actually had to be able to tell when a question didn't have an answer. And that's actually pretty complicated. Most generative systems now have no idea how to say they don't know. So we had different kinds of answers, like blocks and exact answers. So we would assess things as being incorrect or correct, but also inexact. You almost had the right answer, or unsupported. You had an answer, but it wasn't actually supported in the collection. Let me go back a second to say that when systems gave an answer, they had to also give a document that went with that answer. So if the document they gave didn't support the answer, even if the answer was correct, it got marked unsupported. And we had assessors who would review the answers manually to determine these labels. Okay. Okay. So the problem here, returning to our evaluation desiderata for a minute, is that this isn't reusable. Okay. The assessors judged answer strings. And if you take a system and you change it, it's probably not going to produce this exact same answer string next time. Okay. So it's the data set that we produce isn't reusable. So our brilliant idea to try and fix that is to write regexps for the answers. And so actually, if you go back to the old Trek data sets, there are sets of what are called the patterns that you can use to see if the answer your system produces matches a regular expression that was based on the correct answer. Now, patterns were nice in that they produce rankings that are highly correlated with the manual assessments, but that's really not surprising because the patterns were based on the answers and they all came out of the same set of systems that were judged. So this isn't really surprising. When questions are ambiguous or they're long, or we have answer stuffing situations where systems are trying to pack a lot of things into the response, patterns, of course, don't work very well. But this is 1999, 2000. This is many of you may not have been alive when we started this. Okay, that was kind of low, but let me do say that if I came to NIST in 2001, so this starts before Ian at NIST time. So actually, it's kind of before I was quote unquote born in IR either. I figured out I could pull up the chat line. So actually, if people want to ask questions in the chat, I could try and field those. Okay. All right. So alongside QA, we were also running tests on summarization. So this is, we would give you a single document or a set of 10 documents, and the system would have to produce a summary limited to a certain number of bytes. So you had 400 characters to write a summary. And this task kind of grew over the years where we thought about how, because really the task is pretty critical and we didn't have a very good concept of the task and how to design it. So we looked at focus summaries, update summaries, summaries with a given set of questions to cover. That's going to come back in a minute. Summaries that are focused on summarizing concrete information or summarizing viewpoints or making comparisons. And we try to do all kinds of things. So, and as you might imagine, systems were better or worse at this kind of task depending on what we did. This is the early 2000s. So let me tell you how systems solved this problem in the days, we're going to call these days BC. That's before ChatGPT. Okay. So in BC, systems did summarization by searching a collection for passages, not entire documents, trying to then identify the bit in the passage that had the answer, or that wanted to be included in the summary, snipping that out of the passage, and then pasting everything together into a paragraph. So this is cut and paste summarization, or what we call extractive summarization. Now, as you might imagine, when you do this, you get outputs that are really stilted. One sentence doesn't lead into the next sentence at all. It feels like a set of bullet points that got mashed together. Systems usually didn't know how to order those things, so there was no logical flow or anything. Grammaticality was out the window because the sources for the cut and paste, had things in different tenses and different persons. So you get really awful looking summaries. Which is why using the data back from those days is kind of difficult. So the systems actually were pretty bad. Now LLMs, of course, do this differently. LLMs aren't cutting and pasting, except in the sense that they're predicting a sequence of words. If you imagine that the starting prompt only has a single passage through the network, then maybe it's like regurgitating a known answer. But neural networks, of course, don't work that way. So we would have, in those days, called this abstractive in the sense that it's composed rather than assembled. But these days, we're just calling it generative, okay? And LLMs are, produce fluent text. It's grammatically correct. The persons agree, the tenses agree. So those problems which seemed insurmountable in the BC days are gone. We still have a lot of good issues, like getting the right answer, or having good logical flow, or how the output is organized. We're still kind of measuring that stuff. In both of those cases, we have a baseline evaluation idea where we can ask the question, does the summary cover the main concepts that occurred in the documents? So if I can imagine if I gave you a pile of documents and you imagine, here are the key points. I could then ask, well, does this generated summary address those key points? If it does, it's good. If it doesn't, it's bad. So the leap we're going to make here is that nowadays when we say generated content, we're going to use that where we used to say summary. Okay? And you'll catch me at this because sometimes I'll say summary when really what I mean is generated output, and that's our generated content. Really, I'm talking about any generated content at all. Okay, so it doesn't have to be a summary. It could be the answer to a question. It could be a recipe. It could be an image, like the one I asked ChatGPT to generate for me, imagining what itself looks like. Generated content is going to take the place of summaries that we evaluated back in the 2000s, the BC days. Well, how did we do that? I hear you ask. Actually, I don't hear you ask, but if you shout loud enough, I bet the bikes at the PA might pick it up. So when we started this, we first started looking at quality indicators, and then we came up with a couple different ways of trying to compare a known good summary to a summary that a system produced. So we started out with these quality questions like, are there capitalization errors? Are there pronoun fails? Are there ungrammatical sentences? Do the subject and verbs not agree? Are the sentences in a random order? Are there nouns that could have been pronouns? All the things that your English teacher circled in red pen when you handed in your homework. And these were all, of course, these were answered on Likert scales or as binary yes or no decisions. Now, this is a lot of questions. So we simplified this down after we've been doing it for a few years to just 7 questions about the quality of the answer. And these were answered on Likert scales. Okay. Now, these are nice questions about the quality of the summary, but when you ask these questions with Likert scale answers, it doesn't really tell you where the failure was. So that's not explanatory. Okay, going back to our desiderata, it doesn't help me build a better system. It tells me what I need to do, but it doesn't really give me a pointer about how to do it. Okay. So because of that, this was a method that Chinyu Lin, who I guess at the time was at ISI out in California, came up with this model called C, summarization, evaluation. I forget what the other E stood for. When we had this new process, and he actually wrote the tool for this, where assessors would create manually, they would write a model summary. Okay, so their job was they would write a summary by hand, and we called that the model. And then we could compare the model to the ones generated by computers, what we called the peer summaries, in order to judge them. And actually, peers could be system generated. They could be other manual summaries. And in fact, we would generate multiple model summaries and then toss those into the mix to see how they compared with what systems were producing. The model and the peer each get segmented into units, which in those days were, as we begun, basically sentences. And then someone would basically drag a model unit to a peer unit if that unit covered what was in the model unit. Okay, so I'm going to match the sentences in the model to the sentences in the peer that basically say the same thing. Okay, then we would rate how good that alignment was on a per content unit level. So this is the seed of an actual mechanical, a useful evaluation method, because you can imagine if your system, now I'm telling you that this sentence doesn't match the model, or this sentence does match the model, and now you can begin to see where your system might have made a mistake. Okay. Now, one thing that we found is that we got really bad agreement on peer unit, model unit alignment. It really seemed inadequate to use a single model for scoring. But the more models you have means the more assessments you have to do, because you have to manually align the peer units against model units for every model. Okay. And of course, this isn't reusable. So this led to the development of Rouge. I don't remember if I've got a slide on Rouge. Oh, I do. Okay. So Rouge, people wanted to try and automate this. So Rouge is essentially word n-gram overlap between the model summaries and the peer summaries. Okay. But we didn't want to call it word n-gram overlap, and so they call it Rouge. Okay. And there are a bunch of different variants depending on how you do the scoring and what kind of n-grams you look for and things like that. Okay. Rouge was amazing at the time. Rouge had impossibly high correlation to manual assessment, which was amazing. And the reason the correlation is so good is because the n-grams line up. The systems were cutting and pasting from documents, and the manual summaries were essentially cut and pasted from documents and then massaged together, because that's how people would write those summaries. Okay, so having n-gram overlap was really easy to achieve. Nowadays, I would expect Rouge to do a lot more poorly because LLM has a lot more options in terms of word choice, right? It can veer off in different directions. So the n-gram overlap is going to be different. So this is a reason why Rouge isn't such a good metric for what we're doing these days. All right. So in response to the peer and model unit structure from C, this is a method that was developed by Rebecca Passanu and Annie Nenkova. I think they were a Penn at the time, actually. And they came up with an idea for how to approach this problem. They called nuggets and pyramids. So the process starts pretty similar. The assessor creates a model summary. Based on the model summary, the assessor then defines a set of nuggets. In the original duck evaluation, these were called summary content units, or SKUs. Okay, and these were some atomic pieces of information that the assessor expected to find in the peer summaries. Atomic information is really hard to define, but what we were trying to do is get it so that you could match a nugget against a sentence and not require that the information span more than one sentence to be conveyed. Okay, so that was our kind of working definition of atomicity. They had much more linguistic definitions of it, but really this is the motivation of it, is because we were doing sentence-based alignment of the nuggets against the output summaries. We would use 3 more assessors to create a model summary and create their own nuggets. That's nice because now I've got 4 summaries and I can play with Rouge, which people really liked. Then the different assessors come up with different nuggets, and some of them are the same. So we weight the nuggets depending on how many assessors proposed it. And that's the pyramid. Then the nuggets are aligned against the peer summaries. These are easier than peer units because the nuggets are more abstract, okay? They're more atomic than a sentence in a peer summary or in a model summary. And the scoring is easier because I have this weighted nugget recall metric that I could use. Okay. So this is circa 2005, 2006. Okay. Now, this is the state of the art for a while. It's not the only thing we were working on. At the same time, Ed Hovey had developed a technique that he was calling basic elements that was looking not for nuggets, but more for like head relations and sentences. So it was a lot more linguistically motivated. Again, people were trying different things. But the important thing is that nuggets were really flexible. In Duck, these things were atomic pieces of information that you expected to appear in the summary. But you could actually have nuggets that were really different than that. You could have a question that you needed the summary to answer. And then you could say, well, what sentences in the summary actually answered this question? You could ask for sources you needed the summary to cite, or entities or events you needed to be mentioned in the summary, or viewpoints that you needed the summary to cover. Okay? You could model all those using nuggets. Making them atomic so that the alignment works well is a little tricky, but this is amazingly flexible, right? This is no longer about did you convey the information? It's also about how did you convey me the information? What did you decide was important and what did you decide wasn't? So when I do alternatives like this, the evaluation comes much more models what kind of a task I have. Okay, why is the person asking for this summary? All right. Now, nuggets didn't do a lot of things, and they still don't do all of them. So one thing that you can't do with nuggets is there's no concept of negative nuggets, like information you don't want to appear in the summary. You ask, oh, this is going to be nice and political. You ask ChatGPT about causes for autism, and the output tells you that vaccines cause autism, and that would be a negative nugget because it's not true. You would not want it to be there. And in fact, you could imagine penalizing a system, but we never did that. Okay, it never really happened because the source documents for summarization were news articles, and the news articles in the United States from major news outlets tended not to have false information in them. So you didn't really have this come up a lot. Okay. We don't have any way to do nils. So like an idea that a piece of nugget information that isn't discoverable, so that the summary could say, I can't actually answer this question which you care about. When we have hallucinations, which is something like vaccines cause autism in the summary, we score those the same as irrelevant content. But actually, they might be worse because hallucinations might be harmful, or irrelevant content might be harmful, and maybe that's really bad. So you want to be able to differentiate between stuff that's just wrong and stuff that's harmful. We didn't really do that with nuggets. And we didn't talk about order of presentation or logical flow at all. And we still don't do that, mostly because the models seem to do that pretty well, but we don't, there's a lot of room to be done on the logical flow state. And maybe most importantly, we're still doing this nugget creation alignment manually. So it takes a long time, and it's kind of that's for that reason it's a little bit expensive. And because the nugget creation and alignment are done manually, they're not reusable. So here's kind of the generic process where optionally we might just ask the assessor to compose a model output, make their own generated response. And that's nice because it actually makes it easier for the assessor to compose nuggets. Then we actually to make nuggets, maybe 10 or 20 nuggets is a good number. The nuggets should be small so they can be addressed in a single sentence. complicated nuggets, you should break them up. So you can think about having and or nuggets where you have a set of nuggets where you only need one of them, or you have a set of nuggets where you need all of them. Nuggets have ratings. We call vital and okay, but you can imagine them being more like a, like a NDC style game kind of thing. And we were trying to arrive at pretty much no more than 25 nuggets. And the reason is that it's hard to keep, when you're doing the alignment task, to keep all the nuggets in mind. And so it's kind of hard on the cognitive load. All right. The next thing we do is review citations in the generated output. I didn't mention this, but in all the generative tasks in Trek, systems not only have to give us their output, they have to cite where that information came from. And for most tasks, that's done on a sentence basis. So after every sentence, there's a set of citations. And the assessors will decide, does the citation support the sentence it's being cited for? Okay. If the sentence says something and it cites a citation that has nothing to do with that sentence, that's a hallucination. The next part of the task, step 4, is to align the nuggets to sentences that are supported by their citations. Okay, that's nice. By getting rid of all the unsupported sentences, I don't have to do as much. And then if a sentence doesn't cover any nuggets, but it's still really interesting, maybe I should make a new nugget, or maybe I should have a bucket for topical but useful, not really useful nuggets. In some ways, the opposite task, the opposite approach might be taken, where you say, well, it's only relevant if it covers a nugget, and otherwise it's not relevant at all. So there's different ways of approaching that, and the different tracks in Trek that we're doing generative tasks this past year took different approaches here. That was intentional because we're all bozos on this bus. I didn't want us to decree that we would only have one evaluation metric. I really wanted the community to be able to explore that question. Okay. Now, we can make nuggets better by when we do the alignment, for example, because if we say, well, did the output address nugget number 3, that's easy to label. It's just a yes/no answer, but it's not very helpful, again, because you don't know what part of the summary missed it, or if any part of the output might have gotten close. If the answer is no, how do you figure out why? So one thing to do is one thing that we do is we break the output into sentences. We do the alignment by nuggets on a sentence by sentence basis. Now things are a lot more granular. But if my nuggets aren't atomic, then I have a problem, because if it takes 2 or 3 sentences to address a nugget, then no individual sentence will cover the nugget. And you've got a bit of a problem that you have to deal with there. Okay. It's hard to say, well, this sentence partially covers the nugget if I have these other 2 sentences, right? This sentence by sentence chunking works actually pretty well right now. And that's because, and this is kind of an anecdotal observation, but the current models are very sentencey. They tend to generate sentences that hang together well by themselves. And they put them together in paragraphs. If you look at individual sentences, you imagine them being all by themselves. They're actually pretty well closed, if you think about it that way. I haven't measured this. This is just my kind of unscientific observation from looking at generative outputs. They're sentencey. I think that's because sentence endings are a token. So maybe that's part of the game. All right. You might try a cool trick. We actually tried this one year, where rather than aligning the nuggets by just clicking on the sentence, you might highlight the exact portion of the output that addresses the nugget. Just click and drag a highlight bar across that part of the text. This is neat, but actually it's manually challenging. It's a great way to give people repetitive stress injuries. Your hands get really actually your fingers and wrists get painful if you do this for more than a few minutes. And it's also hard to get consistent. Why is it hard to get consistent? Because meaning, which is what really a nugget represents, isn't necessarily conveyed by contiguous spans of text. So people get hung up in, should I highlight this particular word or not? Where do I stop highlighting? Okay. But meaning in words and sentences are different things. This is one of the fun things about language. So it's kind of a rabbit hole you don't want to go down. It's interesting because there's this tension between the granularity of the nuggets and the granularity of the output that maybe is worth thinking about in terms of how we design nuggets. But you want to keep this interaction simple as possible. Okay, now let me talk about automating the process, because that's what we really want to do. We want to be able to automate this, because if we can automate it, then it might be reusable. So the automated process takes the 4 steps and actually reduces it to 3, right? One thing might be to compose a model output. We don't do that in the automation, because this is what the systems are supposed to do. They've already done that part, and we're trying to measure that. We might ask a system to compose nuggets, or to review citations, or to align nuggets to sentences that are supported by their citations. Okay, so these are 3 automation targets for the nugget process. And we tried a little bit in all 3 of these areas in Trek this past year, and all those papers are still in press and under review. So I can't really tell you if they work or not, or if other people liked them. These are just kind of ideas that we were playing with. Okay. And if our papers get accepted to conferences, which I won't mention because you might be reviewing for them, then you'll get to read all about it. Okay, so if I want to compose nuggets for automation, so the way that we did this is we of course we wrote prompts. We constructed long prompts for LLMs to create nuggets, and these prompts would have a user story. The user story tells why the user is asking this question. Why do they want this output? What are they going to do with it? A task specification. So what's the specific thing I'm looking for, or a topic or a question? And that prompt also might include relevant documents or nuggets that the person already thought of that went with that answer. So you can imagine writing this prompt for an LLM to say, well, I'm interested in the causes of autism, and I go into a long bit here about why I care. I care about that because my kids have been diagnosed with autism, and I'm really interested in how that treatment works and how I make sure they're successful later in life. And so, for example, I would like the output to answer these 3 questions at least. And here are 5 research papers from NIH that talk about autism studies. Okay, so that would be the kind of prompt we would put together. And then, so to get that to the system generates some nuggets. And then we give those nuggets to an assessor and have them review them, or edit them, or add or delete from that list. Okay, so this is start with an LLM for suggestions and give that to the assessor to review. So with human review. Okay, so that paper is under review right now, so I can't tell you how well it worked. I apologize if you're the reviewer on this paper, as well as on this paper. We did something similar for assessing support. So if you want to cite, if the citation supports the sentence, then we include the sentence, we include the document, and we have a description of the task. So you can imagine what that prompt looks like. And then again, we would review the output with a human assessor. The specific comparison we did is to compare manual citation assessments. So this is where a human being looks at the citation and looks at the sentence and decides if it supports. And another case where we ask the system to output decisions, which were then reviewed by a human. Okay. So the judgments in each case are pretty similar, not exactly the same, but not too off base. And when you do the human review, of course, it gets better. We found that it takes the same time to assess a citation for from first principles, or to review it when it came out of a system. So that it doesn't actually save a lot of time to have a system help you out there. But if you decide to take some of the answers from the model for as truth, like let's skip all the things the model said, all the sentences the model said weren't supported, and just not look at those, then you can save a lot of time. But again, that means that you're kind of relying on that level of the system. It's not a wholly on, it's not a bad idea to do that for a couple different reasons I'm not going to go into right now, but it should be carefully thought out. So that's support. And then aligning nuggets. So this is the same approach, and we compared automatic alignment of nuggets to manual alignment of nuggets. Okay, so we have the exact same set of nuggets, and we have the system does it and a person does it. And again, the agreement is kind of middling. And we didn't look at post editing, so this is really a first attempt at looking at this part of the problem. So the answer right now is you can't really do this yet. It doesn't work yet. It kind of works. It's tempting for it to work, but it doesn't completely work. Okay. And that's okay, because these are the first attempts. I mean, what are we doing? We're prompting an LLM and taking the outputs. It's not like a lot of intense development is going on for these concepts here. I'm sure there are richer ideas we can employ here. Okay. You know, one thing I do want to kind of wind up with here is the automation is not without risk. Okay. You know, when you take let's say an IR system or a classification system or something, let's step away from the generative outputs for a second. Just think of something simple and familiar like ranked retrieval evaluation. If I'm comparing a system output to a manual answer key, then what I'm asking, the question I'm asking is how does the system compare to a human, a specific human? Okay. If I have a system generate the answer key, then the question I'm asking is how well does my system compare to this other system? Which might be an interesting question, but it doesn't tell me whether it's any good or not. Because if I want to say it's good, that means I have to decide a priori that the answer key generating system is really good. So this has some logical issues. The first one is that if the system that's generating the answer key is so good that I'm willing to rely on it as truth, why are we doing the experiment? I mean, just deploy the system, you're done, right? You have a system that you believe is perfect because it generated an answer key that you trust. Why don't we just use that system? IR is solved. You have some other technical issues like, if the answer key system is part of the experiment systems, which is always the case, right? People want to use the latest model to put in their systems, and we would, of course, want to use the latest model to generate output. So we have a risk of bias. There's a couple of published papers out there that show that models tend to like their own output. And then it gets worse, right? When a new model comes out next month, we have a complete mess. Okay, why do we have a complete mess? Hang with me here. In the answer key evaluation, the best that the system can possibly do is to make labels that exactly agree with the answer key. Okay. If I want to think about this in terms of an IR system, the best IR system is going to put all the judged relevant documents over all the judged non-relevant documents. There's a huge number of ways to do that, but that's the main perfect system. Okay. Now, if the system disagrees with the assessor about a document, this could be one or two, maybe it thinks that the assessor judged something relevant but it wasn't relevant, or the other way around, it's just something that's not relevant, but it really was. Or the system finds some new relevant document the system didn't review. That system is scored as less than ideal. Right? They have to be, because those answers are wrong, because the answer key is always right. We have an answer key evaluation, the answer key is always right. Okay. So I can't show that the system is better than the answer key. If the system produces things that are better than the answer key, I'm stuck. Okay. So, this is another way to think about this is that the answer key is created by a person. With this evaluation, you cannot demonstrate so-called superhuman performance. It's not possible mathematically. You just have an arithmetic problem. Now, if the model is part of the system that I'm trying to measure, it might look the same or worse than the model used to create the answer key. So we really can't tell the system has anything useful beyond the answer key system. We're kind of in a mess. And next month, when a quote unquote better model comes out, it can only look worse because it's going to differ more and more from the answer key that was generated by an earlier model. Okay, so all new models look worse than old models. Okay, this is why it doesn't work. You can't use the system to generate irrelevance judgments. Now, this is not a completely new mess. Human assessors disagree with each other, and systems perform differently than one another. So, disagreement's kind of normal. That's a normal fact of IR. And in an IR experiment, we actually can't measure a system with kind of beyond that level of agreement, right? If there's a gap, if I take two assessors and I find there's a gap between the measured performance in two systems, then that's kind of an error bar on the possible measurement I can make. Okay. So if systems are performing in that zone, we really actually can't say whether they're better or worse. So the moral of the story there is that you can't demonstrate system improvements with automatic evaluation unless you update the model and bring in brand new uncertainty. So in order to do this, you need some level of human assessing. You can use that human assessing to privilege the model that's generating the answer key, like giving it manual relevance judgments that the participating systems don't know about. And that would privilege the answer key model. The answer key model has more knowledge than the participating systems. And now its answer key might be useful. Or you could come up with something like you could measure something that's different than getting the answer key right. Like you could have an extrinsic task. You ask the person to take the output and write a report, and you measure the quality of the report. Okay. In those cases, I can use an LLM generated answer key and have reliable measurements. But the simple thing to do of just generating relevance judgments and using that to measure your system has problems, as I demonstrated. So to summarize, and I'm sorry I'm running a little late. I wanted to give more time for questions, but we have some techniques for evaluating generative content. They're old, they're well studied, and we're trying to adapt them to make them more reusable and less expensive. But the more automation you get, you still actually need some humans in the loop, because even if you have a completely automated metric like Rouge, you probably want to know if it correlates to human judgment. So you're going to need human judgments anyway. Pyramids and nuggets are really adaptable. And so that's kind of nice. You can model a lot of different user tasks with them, and that there's a lot of parts of that process that are good things to try and automate. And it's not, of course, the only way you could do these evaluations, but that's currently our direction in Trek. All right. Thanks, everybody. I can take questions.
Thank you so much.
Oops. Why is it? Oh, okay.
Okay, let me come here so you can see me a little bit. So yeah, thank you. It was great. Very interesting thoughts about what evaluation looks like today at Trek for these generation tasks. Any questions from the audience? Or online? If you're online, have questions, please feel free to unmute yourself. So I'll start with a question while people are thinking. So about the nugget-based evaluation, you mentioned that there is one way to ask LLMs to come up with nuggets, and then you ask your annotators to basically revise those nuggets, if I understood correctly. Mm-hmm. I'm just wondering, how would that kind of introduce biases for that particular LLM? So for example, if we use that LLM that is generating the nuggets in our system, would these evaluation is basically prefer or basically would assign a higher score to that LLM, or?
Yes and no. So yes, because what I have now is a priming problem, right? I've given the assessor kind of a hint, and they're gonna focus on that hint. This is a known psychological phenomenon. I think it's called priming. That's how I think about it. There's a lot of published work on that. But remember, the systems I'm trying to measure are not tasked with making nuggets. They're tasked with producing a generated output. So the system would have to generate nuggets and then find information that answered the nuggets, and then stitch that together into a response, which seems a little bit more than just generating the nuggets. So I'm not sure how big the bias effect is, but it's a great question.
Yeah, thanks. That makes sense. I know that when we use these kind of popular LLM eval methods, it's basically they prefer their own generations by quite a large margin.
Yeah. So if you just ask the LM, you give
Yeah.
it the output, you say, is this good or not? It's going to say yes if it generated it.
Yeah, exactly. But what you're doing is a bit basically it's kind of multiple steps these multiple steps that human involvement in revising those nuggets and selecting and editing that might change a lot of that information pieces that.
Yes. And in particular, if I can automate the citation checking and the nugget alignment, but I still have manual nuggets, I probably have a pretty reusable data set. Okay. It depends on the affinity of that alignment and that citation checking, which, any system that does predictions has a false positive, false negative rate. But it's getting us on the road. So that's almost doable.
Yeah. Okay, cool. Yeah, thanks. Any other questions? A question from the audience.
Hi, thank you for the presentation. It was really amazing and great to listen to. I was very curious about when you said that we can't possibly get something to be better than the human, like annotators and assessors. What might you be looking for that would be like better than the humans that we're using as our like baseline of like what is good? Like what we might be looking for it to be like superhuman, better than a human?
Right. Now, I didn't say that we can't get things that are better than humans. Radar is better than human vision for doing things like detecting the distance between a person and a car in front of you. We can do things that are superhuman, but with an evaluation that's based on an answer key, where the goal of the system is to produce the answer key, essentially, you can't measure whether the system is better than the answer key. So you can't use that process with a manual answer key and say, well, this system is better than humans. One thing I can do is I can have a manual answer key and then give the test both to systems and to some other group of humans. And if the system, this is what people do when they give LLMs, law school entrance exams and things like that. Then you might be able to talk about whether the model can outperform a person. And then you end up with the wonderfully existential question of, wow, do these tests actually measure what we care about or not? But yeah, absolutely, you can imagine things that are better than human performance. The goal of these systems is not necessarily to be better than human performance, though. The goal of these systems is to help people solve their problems more easily and faster. I want people to be more productive, more accurate, more confident in the information product that comes out at the end than they might have done otherwise. Okay, so I want to make a system that helps make that person better.
Final questions.
Thank you for the talk. I had one question about like how these nuggets might be useful for evaluating like reasoning kind of tasks, which might be more difficult, right, compared to these like factual tasks.
Now, when you say a reasoning task, do you mean like generating a mathematical proof? Or do you mean like kind of...
Yeah, it could be like a mathematical reasoning task or also something like common sense reasoning.
Okay. So haven't done this. So I'm talking about, this is a hypothesis. I think that you would want to zoom in on the logic, the kind of the logical transitions that you would expect to occur. So you want to kind of find the if-then junctions in the logical reasoning that you're aiming for and see if the system crosses those boundaries correctly. Okay, so if the question is, as I see a person walking down the street, they're carrying an umbrella, does that mean the weather forecast is for rain? and you can imagine say, well, people might carry umbrellas for lots of reasons, but if it goes the other way and says, well, people, when it rains, they carry an umbrella, then you could identify that one of those is reasonable, one of those isn't, for example. But I'm not sure. I haven't done this before, and so it's tricky. Yeah, I think one of the reasons it's tricky is because there are a lot of logical paths that you could take, and it's not clear how you cover them all. But I'd love to see some work on it. I think it's a neat idea.
Okay, let's thank Ian one last time.
Thank you all. Thank you for your hospitality.
Thank you so much. And we're looking forward to the follow-up meeting. So there is another link that
Yep.
sent you. So please join that. And it probably takes us a couple of minutes to go upstairs and set up for that meeting.
Oh, excellent. I'm gonna go take a bio break and I will be there.
Okay, awesome. See you soon. Thanks,
All right.
everyone.
Thank you all. Thanks for the questions.
Bye.